Hello everyone, this is Dave's Fancy Science. Today we're going to learn how to make an agarose gel. The purpose of gel purification is mainly to isolate the pieces of DNA that we want to according to the length of it. This is a brief picture of how it works. DNA is negative, and because a positive charge attracts a negative charge, we can use a positive charge at that end to pull the DNA along the gel. However, the gel where we put the DNA into is very meshy, so the small bits and pieces of DNA will come to the front because it is faster and will not be blocked by the meshes, and the bigger ones will get behind, so we can sort them according to the sizes. However, there will be DNA nases that cut the DNA into pieces and mess around our results. So there will be a lot of chemicals in the gel that inhibit DNA nases from working. Alright, here's how we make the gel. Firstly, dump 0.3 of agarose into the conical flask. The agarose is the thing that we mentioned before that makes this type of meshy component that makes DNA hard to move. Secondly, fill the measure cylinder with 30 ml of TAE buffer. T and A stands for tris and acetic acid that keeps the pH neutral that fits DNA, and E stands for EDTA that gets rid of ions that enable DNases to work, which DNases will cut DNA and affect our product. And secondly, to enable lighting, which help us to visualize it. Thirdly, dump the TAE in the cylinder into the conical flask. At this point, you can see a bunch of white fluid with particles. It's definitely not mixed. So, to dissolve the solution, we need to put it into the microwave till it's clear. After that, we mix it to cool and add DNA dye. We need to make it cool.
Just cool, then into.
And we need to add the DNA dye, for example, number red, because that the DNA that we want to detect gets color so we can see it. In addition, it is also very important to notice that this DNA dye can get onto your DNA and cause cancer, so you must be very careful with it. After that, dump the gel into the mold so it can dry. There's something to notice. Firstly, below the mold, you need to add a small tray that you can put out along with the gel when you want to use it. And in addition, you need to insert the comb-like thing to make pores that we can put DNA into it. After that, wait 30 minutes for the gel to clog. After 30 minutes, we pull out the comb to expose the holes, and then pull out the tray so that we can have the gel that we need intact in our hands. Also, you can notice that the comb makes several holes in the gel that we're going to put the DNA into it. Finally, soak the gel into the DNA buffer and eject the DNA samples and dye into the holes, which fancily we call it loading the gel. And then you set the numbers correctly and you can wait for it to run the gel. Firstly, put agarose into the weighing paper and dump it into the conical flask. After that, get 30 ml of TAE buffer into the measuring cone. We typically use a tap in our lab. After that, dump your full tube of TAE into the conical flask. As you can see, no matter how hard we try to mix the powder and the TAE, it doesn't work, so we need to put it into the microwave. And there you go. Set the time to 2.5 minutes and wait for it. After our microwaving has done, we use heat-proof materials to get it out of the microwave. We can mix it to make it cooler, but if we don't, it's totally okay. And then Eject the DNA dye into the conical flask. We cool the flask, actually, so that the DNA dye will not break up into smaller particles, which we do not want it to. Next, pour your liquefied gel solution into the mold. You can see that there is a tray and become like this. Next, you can load on ladder to show reference to our DNA. The rest of the process is pretty easy. As you can see, this is DNA being cooled by electricity moving through the gel. In this video, you'll learn how to make an agarose gel and the inner workings of it. Please scan the QR code to follow me on Dave's Fancy Science website, and I'll see you later.